Okay, just to finish up these probability or these assessments, the probability questions, they're only worth a couple of marks each or 3 marks each or something like this. It was I'll do both of them. So that's the question from one paper, very similar to the question from the other paper. So the question was, you roll 2 dice. A is the probability that the two numbers are the same. B is the probability that the sum equals 8. And then you have to calculate the probability of A, the probability of B, and the probability of conditional probability of B given A. In other words, what's the probability of B given that A has already occurred? Okay, so we know that you usually write down the sample space here, and I'm not writing the whole thing down here, but the possible outcomes are 1, 1, 1, 2, 1, 3, all the way up as far as 6, 5, 6, 6. And we know how many of them are. There are 36 possible outcomes. Okay, the number of possible outcomes are 36. There's 36 ways you can roll 2 dice and get different outcomes, okay? So A is the probability that the numbers are all the same. So we write down the set in A. It's obviously double 1s, double 2s, double 3s, double 4s, double 5s, or double 6s. Okay, so we can see 1, 2, 3, 4, 5, 6. So there's 6 ways out of 36, which is 1 in 6. So the probability of A is 1 in 6. Okay, the probability of B is the sum is equal to 8. So B is the sum is equal to 8. Well, you can't get an 8 with a 1. You can get an 8 with a 2. So 2 and 6, or else 3 and 5, or else double 4s, or else 5 and 3, or else 6 and 2. Okay, so obviously there's 5 ways that can occur. So the probability of B is 5 out of 36. Okay, and then the probability of B given A, we need the A intersection B. A intersection B is just 4, 4. Okay, so the conditional probability, the probability of B, which is this B given A, is the probability of B, or A intersection B, B intersection A, same thing, A intersection B, over the probability of A. Okay, so that's the probability of A intersection B. The probability of A intersection B, I should have said, probability of A intersection B is just 4, 4, which is 1 out of 36. So there's a 1 in 36 chance of getting that. So the probability of A intersection B is 1 over 36, over the probability of A is 1 over 6. So it's 1 over 36 multiplied by 6 over 1, which is 1 in 6. Okay. So there's a 1 in 6 chance. So in other words, the explanation there is, given that we know A has already occurred, okay, we know that we've rolled doubles, what's the probability that the two numbers add up to 8? Okay, so what's the probability of that they add up to 8 given that we know they're the same? So there's a 1 in 6 chance. If we know that we've rolled doubles, there's a 1 in 6 chance that they add up to 8. So it's exactly right. Okay, the second version of this question is A's the numbers are the same. That's very similar to the first question. So A's the numbers are the same. So the probability of A is this set here, 1, 2, 3, 4, 5, 6. So 1's 6 out of 36, or 1 in 6. The probability of B is slightly different in this question. Okay, so the sum here is 7. Okay, the last one was 8, so the sum is 7. So the ways we can get 7 are 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. Okay, all those ways. So the probability of B is 6 out of 36 again, or 1 in 6 chance. So there's a 1 in 6 chance that we roll a 7. Okay, it's the most common roll of the whole lot. The next thing is the probability of B given A. So A intersection B is anything that's in both of these sets, and since these are all doubles and the same, and these are all different, the A intersection B is equal to 0. Okay, so there is no intersection of A and B. So what that actually means is the probability of B given A is the probability of A intersection B over the probability of A, which is 0 over 1/6, which is 0. So the answer is 0. Okay, thanks, Phoebe.